Namaskar students, this is the first problem of today's video. If 2 to the power x equal to 4 to the power y equal to 8 to the power z and 1 by 2x plus 1 by 4y plus 1 by 8z equal to 22 by 7, then you have to find out the values of x, y and z. How to do this? See, it is given that 2 to the power x equal to 4 to the power y equal to 8 to the power z. Now see, from here what you get, or 2 to the power x equal to 4 means what? 2 square. So 2 square to the power y equal to what is 8? 2 cube. So 2 cube to the power z. 8 to the power z means 2 cube to the power z. Or 2 to the power x equal to 2 to the power 2 to the power y. So it will be 2 to the power 2 into y equal to 2 to the power 3 to the power z. This will be 2 to the power 3 into z. Now since the bases are equal, hence you can write or x equal to 2y equal to 3z. Now over here you are getting x equal to 2y equal to 3z. So from here we'll use this equation to find out the values of x, y and z. So we got x equal to 2y equal to 3z. Now let us use this equation. 1 by 2x plus 1 by 4y plus 1 by 8z equal to 22 by 7, or 1 by x plus, you can take 1 by 2 common. So if you take 1 by 2 common from all these three terms, what you have inside? 1 by x plus 1 by 2y plus 1 by 4z equal to 22 by 7. We took 1 by 2 common from all the three terms. Now if I transfer half this side of the equation, this 2 will get multiplied with 22. If I transfer this 2, which is in division form, to the right hand side, the sign will get changed. 2 will be multiplied with 22. So I am changing this to right hand side. So it will be 22 into 2, that is 44. Now see, 2y means x. So you can write this as 1 by x plus 2y means x plus 1 by x plus, see over here 3z, from here you can tell 3z equal to x or z equal to x by 3. So in that case 1 by z will be equal to 3 by x and 1 by 4z will be equal to 3 by 4x. So 1 by 4z will be equal to 3 by 4x equal to 44 by 7, or 1 by x you can take common. Inside what you have? 1 plus 1, that is 1 plus 1, that is 2, plus 3 by 4 equal to 44 by 7, or 1 by x into, to the LCM, this is 2 by 1, that means 8 plus 3 equal to 44 by 7. or 1 by x into 11 by 4 equal to 44 by 7, or now 11 by 4, if it goes this side, it will be 1 by x equal to 44 into 4 divided by 7 into 11. So 11 4s are 44, 4 4s are 16 by 7. If 1 by x is equal to 16 by 7, then x will be equal to 7 by 16. So the value of x is 7 by 16. 1 by x equal to 16 by 7. Hence, x will be equal to just the reverse of this, 7 by 16. So you got the value of x. Now, since we reached at the value of x 7 by 16, from this equality we'll find out the values of y and z also. If x is 7 by 16, from here these two equations, what you have then, 2y equal to x or y equal to x by 2. Hence, if x equal to 7 by 16, then therefore y equal to x by 2, that is equal to, x means 7 by 16 into 2, that is 7 by 32. And from here x equal to 3z, so you have x equal to 3z, that is 3z equal to x or z equal to x by 3. Therefore, z equal to x by 3, that is equal to 7 by 16 into 3, that is equal to 7 by 48. So x equal to 7 by 16, y equal to 7 by 32 and z equal to 7 by 48. This is our next problem. Let me just read it out. E to the power 2x plus e to the power minus x minus e to the power x minus 1 divided by e to the power 2x minus e to the power minus x plus e to the power x minus 1. You have to prove this expression is equal to e to the power x minus 1 divided by e to the power x plus 1. Let us try to prove this. So LHS is equal to, see, e to the power 2x can be written as e to the power x plus e to the power minus x minus e to the power x minus e to the power 0. Actually, what is happening, see, anything, any non-zero number a to the power 0, we know that is equal to 1 according to the primary law of indices. Any non-zero number whole to the power 0 is equal to 1. Now see, this 0 can be written as, over here what I have written, e to the power 0. In place of 1 I have written e to the power 0. Now this 1 equal to e to the power 0, this also can be written as equal to 0 means what? X minus x. We can write 0 as x minus x. So 1 can be written as e to the power x minus x. So directly we can write 1 as e to the power x minus x divided by, same thing, e to the power 2x means e to the power x plus x minus e to the power minus x plus e to the power x. This minus 1 can be written as e to the power x minus x, which is equal to, see, e to the power x plus x means e to the power x into e to the power x. According to the law of indices, e to the power x into e to the power x, since the bases are equal, you can write this one as e to the power x plus x, this. So instead of this e to the power x plus x, we can write e to the power x into e to the power x plus e to the power minus x minus e to the power x minus, now this also can be written as e to the power x into e to the power minus x divided by e to the power x into e to the power x minus e to the power minus x plus e to the power x minus e to the power x into e to the power minus x. Now see, let us take common. See, from the first term and the third term, first term and the third term, let me just rearrange this. So if I rearrange this, it will be from the first term and the third term. If I take e to the power x common, first term and the third term, what remains inside? E to the power x minus 1. So if I take e to the power x common from this term and this term, it will be e to the power x minus 1. Again, plus, if I take e to the power minus x common and take a minus over here, see, e to the power x, I am e to the minus e to the power x, I am taking common, minus of e to the power x from the remaining two terms. So what it remains? E to the power x minus 1. See what happens if I multiply this. Let us see if this comes or not. This into this, e to the power x into e to the power x minus e to the power x minus e to the power minus x into e to the power x minus minus plus plus e to the power minus x. So see, e to the power x into e to the power x, okay, plus e to the power minus x plus e to the power minus x minus e to the power x minus e to the power x minus e to the power x into e to the power minus x minus e to the power x into e to the power. So rearranging this numerator and taking e to the power x and minus e to the power minus x common, you get this expression divided by, now the same thing, take e to the power x common, inside what you have common from the first term and the third term, you have e to the power x plus 1, take minus e to the power minus x common from the second term and the fourth term, inside what you have e to the power x plus 1. You can perform the multiplication in your copies and you will see, you will arrive at the denominator, same thing. So just rearranging these terms and taking common e to the power x and minus e to the power minus x, this denominator can be written as this. Now see the interesting part, what happens, equal to, in the numerator what you have, e to the power x minus e to the power minus x into e to the power x minus 1 divided by denominator also e to the power x minus e to the power minus x into e to the power x plus 1. See, e to the power x and e to the power minus x, these two are not equal. Since these two are not equal, e to the power x minus e to the power minus x cannot be equal to 0. Since this term and this term are not 0, you can cancel these two terms and what remains? E to the power x minus 1 divided by e to the power x plus 1, which is nothing but the RHS. Hence, we have proved that this LHS equal to e to the power x minus 1 divided by e to the power x plus 1. This is the last problem of today's video. If 7.77 whole to the power x equal to 0.777 whole to the power y equal to 1000, this is equal to this equal to 1000, then you have proved that 1 by x minus 1 by y equal to 1 by 3. See this one, solution, 7.77 whole to the power x equal to, you have 1000. Okay, now what is the meaning of 1000? 1000 means 7.77, that is equal to whole to the power x, equal to 10 cube. 1000 means 10 cube. See, by the law of indices, if a is non-zero and a to the power x equal to b to the power y, then you can write a as b to the power y by x. Okay, you can write a equal to b to the power y by x. So this also can be written as, if 7.77 whole to the power x equal to 10 cube, then you can write 7.77 equal to 10 to the power 3 by x by using this law. 7.77 equal to 10 to the power 3 by x. Now coming to this one, this also 0.777 to the power y equal to 1000, or 0.777 whole to the power y equal to 1000 means 10 cube, or 0.777 equal to 10 to the power 3 by y. Now let us try to equate the left hand side. Means this is 7.77, over here you have 0.777. Let us try to equate these two. Or see, in both sides, if you multiply 10, 0.777 into 10 equal to 10 to the power 3 by y into 10, means 10 to the power 1 actually. Or now say 0.777 into 10 means what? It will be 7.77. If you multiply with 10, this decimal will move one level after. So it will be 7.77 equal to 10 to the power 3 by y into 10 to the power 1 means 10 to the power 3 by y plus 1. Now see, 7.77 means 10 to the power 3 by x, and also 7.77 means 10 to the power 3 by y plus 1. So from these two you can tell that therefore 10 to the power 3 by x is equal to 10 to the power 3 by y plus 1, or since these two bases are equal, so the powers 3 by x will be equal to 3 by y plus 1. From here you have, if you bring this 3 by y left hand side, you have 3 by x minus 3 by y equal to 1, or take 3 common, what you have, 3 into 1 by x minus 1 by y equal to 1. If you take 3 common from both the terms, you have 1 by x minus 1 by y, 3 common, that is equal to 1. Now this 3 is multiplied. If you transfer this 3 on the right hand side, what will happen? Since it is multiplied over here in the left hand side, right hand side, it will be in division form. So now you have arrived 1 by x minus 1 by y equal to 1 by 3. That is what you had needed to prove. My dear students, these 3 problems which we had seen today will be useful for your higher secondary examinations and also for your competitive examinations. If you have understood the problems which we had discussed today, do like my video, share this video with your friends, subscribe to my channel, and don't forget to follow my page. Till then, goodbye.